Hello, my name's Ethan, and I've set the goal for myself by summer 2026 to get my high power model rocketry certification from the NAR. In this video, I'll show you how I made my own high power launch system and how you can do the same. For those who don't know, the NAR, or the National Association of Rocketry, is a national organization that creates guidelines for safe model rocketry. They also issue 3 levels of high power certifications that allow you to buy bigger and more powerful rocket motors. For my level 1 certification, I chose Apogee's Zephyr rocket. It's advertised as being great for level 1 certifications and can take a wide variety of motors such as G, H, I, and even J level motors, which are only allowed for level 2 certification. Also, the kit is of medium difficulty, which means it uses more tools and more materials that may be difficult to use, but the included instructions are clear and easy to follow, and I was able to build the kit with very little difficulty. In the future, I hope to build my own rockets of my own design, but for now this kit worked very well. Just a rocket by itself is not useful. I also need a launch pad which can support large rockets. At first, I looked for commercial launch pads, but that quickly turned out to not be an option I was able to do, so I designed my own. At first, I tried to copy the gun turret launch pad from Apogee, which I would have bought if it wasn't for the price tag. My first design was this stack of 3 PVC tube adapters held together by 1/4" 3D printed bolts. I designed them to bolt together at 120-degree angles, so from the top view they create a tripod. Since all the 3 adapters are at different heights, I would have to slide the PVC tubes in or out so it'll sit flat on the ground. Unfortunately, this design was not strong enough to hold the flexing of the PVC tubes, and the thin 3D prints just snapped right in half. So my next design was to just beef up the adapters and make them much thicker, but I came up with a better design before I could go too far with that. I printed this adapter which could hold all 3 PVC pipes flat against the ground, so it hopefully won't tilt or have any flex at all. But I quickly realized that 3/4" PVC, which I'm using here, refers to the inner diameter, not the outer diameter, which I care about. Also, I only printed space for 1 screw hole, which means that the PVC tubes can flex and bend inside the holders. You can see my final design down there printed in blue PETG. I just made it much wider and added enough space for 2 screw holes so that these PVC tubes can't flex at all. This mechanism up here, which I mentioned earlier, was designed to tilt just the very top part of the launcher, just the metal plate essentially. But what I did right now is I just epoxied it shut because I realized I can just pick up the entire launcher and tilt it over that way, and I don't need a whole complicated mechanism. It was just making the whole thing wobble and wiggle and make it very unstable, and so I got rid of it. My launch rail fits down through this hole and is held in place by these 2 U-shaped clips and sort of sits in that bucket, sort of basket down there. It's designed to hold a 10-101 extruded aluminum rod that's 8 feet long. Even after all that, when it's fully assembled with the rocket on the rail, it still leans over very badly, so I 3D printed these little blue T-nuts which I can hold in place on the rail with a screw. I threaded a little bit of string through one of them, and I'm going to hold it in place down on the ground with the garden stake, and hopefully this should finally hold the whole launcher upright. So with that finally out of the way, the next thing to worry about is how to ignite the rocket remotely. The launch instructions suggest standing at least 40 feet away for a level 1 rocket motor. I'm using the Aerotech H100-14A motor, which is on the low end of H-class motors and should propel the rocket to about 1900 feet. I chose to make some kind of remote control circuit so that I don't need 80 feet of wire going back and forth from the rocket to the launcher. To make the radio control circuits themselves, I followed this great tutorial by StudyCell. He explains how to make a remote controlled relay, which we can use to close the circuit from our battery to our igniter. You can find links to all his components in the description of his video. I essentially just followed his diagrams, turned it on, and it worked. Make sure to follow his tutorial carefully. There's a few libraries you need to install, but besides that, it works fine. The transmitter code works perfectly out of the box and I didn't need to change it at all, but I did want to make one modification to the receiver code to make it work the way I wanted to. Okay, so I'm now in StudyCell's receiver code, and you can totally use his code out of the box. It works just fine, but what happens is it's a toggle, so you need to send one signal to turn it on, then it'll stay on, and then you need to send a second signal to turn it off. And that's not what I want to happen. I want it to just turn on, wait for 1 second or some amount of time, and then turn right back off. And so what we have here is we have these 2 lines of code. This one's responsible for turning on the relay, and this second line of code is responsible for turning it off. And so what we can do is we can take everything inside these curly brackets
just copy it. This is the code for turning it off, and put it in the code for turning it on. And then in between the two, we can put a command, a delay of 1,000 milliseconds, or however many milliseconds you want. 1,000 milliseconds is 1 second. And what this does now is when it receives a command to turn on, it'll turn on, wait for 1 second, and then turn right back off. And now we can get rid of this the old code for turning it off. And now what we have is we have an automatic toggle. It'll turn on, wait for 1 second, and turn off. And it's important that we turn it off after a certain amount of time, because our battery will be delivering a lot of current, and it's not good for the battery to be delivering that current for too long. And so this will just protect our battery, and this should be long enough to ignite our igniter.
Now that I had the functioning circuits, I wanted to put them into something that would make them a bit more useful. I saw a video by Edward Robinson on his launch controller, and I wanted to do the same thing with an old briefcase I had sitting around.
The briefcase works really well because it has a lip that runs all the way around the edge, which makes it really easy to mount this front panel. But it should be easy to mount this onto anything of dimensions of 136.5 millimeters by 216 millimeters, and the CAD files are in the description. The arming switch and these two launch buttons are all wired in series, so all three have to be on at the same time for the Arduino to receive the signal, to send the signal to the transmitter to switch the relay. The only reason I included two launch buttons instead of just one is just so I don't accidentally drop something on one of them and launch the rocket before I mean to. For a safety key, I use the standard AC wall adapter, and what happens is the power to the transmitter first flows through the female adapter into the male, which just loops back onto itself to the other plug of the female, and then finally that can go through to the transmitter. So power can only go to the transmitter if this male adapter is plugged in. And finally, the safety key sticks up high enough that I can't accidentally close the lid before I've taken it out. The receiver box, I wanted something that was fully contained because it was going to be closer to the launch and it would probably get blasted by dust. So it's fully contained. I just am holding it closed with a piece of duct tape right now. And how it works is, on the inside you can see StudyCell's circuit down there. There's the relay there. And 4 pass-through posts on each side. Now how they work is, the black posts are just connected straight through with that big red wire there. But the red posts go through the relay and then connect to each other. And so if you hook the battery leads on one side and the igniter leads on the other, when that relay closes, it'll close the circuit and it'll ignite the igniter.